Hello all. This video is a continuation of memories in system Verilog. In this video, we are going to discuss about associative arrays. So, in the case of normal arrays, the memory is allocated at the time of size declaration. Let us take an example of dynamic arrays. In previous lectures, we have discussed about dynamic arrays. So, in the runtime of dynamic arrays, we declare the size of the dynamic array by using the keyword new. But suppose if we declare the size of the dynamic array as 50, then 50 memory locations will be allocated for this array like this. So the memory is allocated even for the elements which are not used. Here, for suppose, here we have 50 memory locations. So in this 50 memory locations, if we use 30 memory locations and leave 20 memory locations unused, then these 20 memory locations will be a wastage of memory. Here only 30 memory locations are only used out of 50 memory locations declared. So this causes a wastage of memory. So for avoiding this scenario, System Verilog introduces a concept called associative arrays. So in case of associative arrays, the memory is allocated only while writing the data into the arrays. For example, here while declaring the size of the array, 4 memory locations are allocated here. 1, 2, 3, 4. While declaring the size of the array itself, 4 memory locations are created here. Whereas in this case of associative array, the memory is allocated only while writing the data into the array. If we want to write the data in the first memory location, then corresponding location is created for that elements. If we want to write the data in second memory location, then second memory location is created for that. If we don't want to write the data in third memory location, then there will be no memory allocated. Here, fourth memory location is created if we want to write the data in the fourth memory location. So this type of array is useful while constructing larger memories like RAM, therefore there is no wastage of memory. And the index of the associative array can be of any type, that is string type or integer type. The syntax is as follows: data type and the name of the array and followed by index. Let's see an example here. For suppose here we write a module test and here we declare an associative array. This is an associative array. In previous slides, we have discussed that the index of the array can be of any type. That here we have taken int type, and a is the name of the associative array and int is the data type of the array. So in initial begin, we have declared a of 3 equal to 5 and a of 2 equal to 1 and a of 50 is equal to 10 and a of 500 is equal to 20. So in the memory location, at third memory location element 5 will be stored, and at second memory location element 1 will be stored, and at 50th memory location element 10 will be stored. So here we can see that memory is not contiguous. Here we can see that memory is not contiguous, it is non-contiguous. That is, we can store the elements in different memory locations. Here there is no wastage of memory. For example, here let's say this is an associative array of name A, and we represent associative array with symbol asterisk. So if we want to store in first memory location, say in first memory location if we want to store 3, then a of 0 equal to 3. Then a memory location will be created, and in this memory location 3 will be stored. And if we want to store 2 in second memory location, then a of 1 is equal to 2. And if we don't want to store in second memory location, we will not declare it, and if we want to store in third memory location, we will declare a of 3 is equal to 1. Like this, memory will be created according to the data. Like this, memory is allocated only while writing the data into the arrays. So this is all about associative array.